Welcome to MathTuber. So, in the last video, we were discussing three-dimensional geometry and we were doing exercise 11.2. And now let us discuss the shortest distance between two lines. So, shortest distance between any two lines is always the perpendicular distance between those two lines, right? So we have two kinds of lines. One is known as skew lines, so distance between skew lines. So first of all, let us understand what are skew lines. So in a three-dimensional space, if two lines are passing from anywhere, like suppose you are in a room and two lines are passing uh, uh, from anywhere and they are not meeting each other anywhere. So these are known as skew lines. So the shortest distance between these two lines will be the place where these two lines or one line is going above the another, right? So distance between skew lines. So they can be of any length or anything like that. So we will be given with the equations of these lines. So let us say this is TS, this is QP, this is L1 and this is L2, line 1 and line 2. So let us consider line 1 is given, the equation is given R vector equal to A1 vector plus lambda B1 vector. And the equation for L2 is given as A2 vector plus mu B2 vector, right? Now these B1 and B2 vectors are the parallel vectors as we have discussed in the equation of a line passing through a point and parallel to a vector. So these are the parallel vectors B1 and B2 and A1 and A2 represents the point from which the line is passing. Right, so we are going to use these B1 and B2 vector for finding out. So the formula for this is the distance d. Let us say this PQ is the distance, which is the shortest distance between these two lines, is given by B1 vector cross B2 vector dot A2 minus A1 vector divided by B1 vector cross B2 vector uh, magnitude and the modulus of the whole thing, right? Because the distance cannot be negative, so we have to take the modulus at the last. So this is the vector form of the equation. And for this one, Cartesian form is actually a bit larger, which is which we cannot actually learn, right? So I'm going to write that, but most of the time we are going to use this formula only to find out the solution. So let us understand the Cartesian forms now. So in case we are given with the Cartesian form of the lines, let us say the Cartesian equation of L1 is given x1, x minus x1 upon a1 equal to y minus y1 upon b1 equal to z minus z1 upon c1. And L2 is given x minus x2 upon a2 y minus y2 upon b2 and z minus z2 upon c2. So in that case, the value of D will be given by x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, and a2, b2, c2. This is the determinant. This determinant we have to solve and divided by the magnitude of b1 vector cross b2 vector. So that will be a very large value. So it is b1 c2 minus b2 c1 square plus c1 a2 minus a1 c2 square plus a1 b2 minus b1 a2 square, and the whole modulus of the thing. So this is a quite larger formula. So we don't have to learn this one. We just have to learn the vector form, and we can do it. So let us understand the questions from this. So we have the 12th question for skew lines. 12th question is we have to find the distance, shortest distance between the given lines. So the vector form of the equations are given. So the first equation is I plus 2j plus k cap plus lambda I minus j plus k. And the second equation is given 2i minus j minus k plus mu 2i plus j plus 2k. So the shortest distance between these two lines is, so first of all, let us write down the formula, or obviously we know the formula, which is b1 cross b2 dot a2 minus a1 divided by the magnitude of b1 cross b2. So first of all, what we can do is we can find out b1 b2 and a1 a2, that we already know. This one is b1 vector, this is b2 vector, this is a2 vector, and this is a1 vector, right? So first of all, let us find out the cross product of b1 and b2. So b1 cross b2, let us find it out. So now this is ijk 1 minus 1 1 2 1 2. So this will be minus 2 minus 1 minus j 2 minus 2 plus k 1 plus 2. It is minus 3 I cap. This will be 0, and this will be plus 3 k cap. And b1 cross b2 vector will be under root of 9 plus 9. That is 3 root 2. Right. And now a2 minus a1 also, let us find out a2 minus a1, which is 2i minus I is I cap, minus j minus 2j is minus 3j cap, and minus k is minus 2k cap. So D is equal to B1 cross B2 dot A2 minus A1 vectors divided by magnitude of B1 cross B2 whole modulus. So if we do the dot product of these two, you will get minus 3 into 1 and plus 0 into minus 3 plus 3 into minus 2 divided by 3 root 2 whole modulus. So minus 3 minus 6 upon 3 root 2 minus 9 upon 3 root 2. So it is minus 3 upon, or you can say if you remove the modulus sign, you will get the minus sign will be removed. So 3 upon root 2 units, or you can say if you do the rationalization, 3 root 2 upon 2 units will be the answer. So this is how we have to do the questions. Now, if the equation is given in Cartesian forms, obviously we know that the formula is very large. So what we can do is we can first convert our equations of the line in vector form, and then we can apply this same formula there. Now let us understand if we have the distance between two parallel lines, because other than skew lines, we have parallel lines also. So the distance between two parallel lines is always the same. It is same everywhere. So we have to just take out a perpendicular distance. So if we have distance between two parallel lines, uh, if these are the parallel lines, let us say, and this distance we want to find out d. So, and let us say this is L1, this is L2, and vector form of these equations are given. R vector is equal to A1 vector plus lambda B vector, and L2 के लिए this is R vector equal to A2 vector plus lambda B vector. So B vector is common in both, right? So B vector will be common. And if somehow in some question these B vectors are proportional, the direction ratios are proportional, then also they are also parallel, right? Proportionality is the same thing. So you can change the constant here, mu. Yeah. So now we have these two here. So what we can do is we can find out the value of d from here, which is the distance between these two. So b vector is a common vector here. So b vector cross a2 minus a1 vector divided by the magnitude of b vector. So this will be the formula, right? And the Cartesian form we don't have to learn in this case. We just have to use this only. In both the cases, for both the distance between skew lines or parallel lines, we are going to use only the vector form. So now let us do one question from this also. So we have just a second. Well, we have a few questions in this, and there is no such question for parallel lines here. So let us do an example then. So we have an example here, example number 10. There are two vectors given which are parallel to each other. R vector equal to I plus 2j minus 4k plus lambda 2i plus 3j plus 6k. And the second vector given is 3i plus 3j minus 5k plus mu, and the b vector is the same vector here, 2i plus 3j plus 6k. So now we know that this is the b vector. These are a2, a1 and a2 vectors. So a2 minus a1, first of all, let us find out. This is 2i cap plus j cap and minus k cap. So the value for d is b cross a2 minus a1 vectors divided by the magnitude of b vector. So let us first find out b vector cross a2 minus a1 vector here, which is ijk. B vector is 2, 3, 6, and this is 2, 1, minus 1. This is minus 3, minus 6, minus j, minus 2, minus 12, plus k, 2 minus 6, so minus 9i cap, plus 14j cap, and minus 4k cap. So this will be, and now we have to find the magnitude of this. So the magnitude of this is under root of 9 square minus 9 square, actually 14 square plus minus 4 square, divided by the magnitude of b vector, that is 2 square plus 3 square plus 6 square, whole modulus. So this is under root 293 divided by under root of 49, and that is 293 upon 7. This will be the answer, right? So this is how we can calculate the distance between two parallel lines. So we just have to put the formula and find out the answer. Now let us try a few questions from miscellaneous. There are only 5 questions here, and some of them are really easy. So this is the miscellaneous of chapter number 11. So we have 5 questions only, and let us do them one by one. So in the first question, it says that we have to find the angle between the lines whose direction ratios are ABC and B minus C, C minus A, and A minus B. Right. So we know that if the angle between them is given, we can easily find out the answer. A1 cos theta is given by A1 A2 plus B1 B2 plus C1 C2 upon under root of A1 square plus B1 square plus C1 square into uh, under root of a2 square plus b2 square plus c2 square whole modulus. So that is the uh, answer. So now here, when you do the cos theta thing in the first question, because the direction ratios are given, and if you apply the formula, you will get a into mm, b minus c plus b into c minus a plus c into a minus b divided by the whole thing, a square plus b square plus c square into under root of b minus c square plus c minus a square plus a minus b square. And when you calculate it, you will get the answer as 0 only, because the numerator becomes 0 when you open all the bracket. And if cos theta is 0, which means the answer is 90 degree. which means the angle between the two lines is 90-degree here, right? So that's a quite an easy question. After this, we have find the equation of a line parallel to x-axis. If a line is parallel to x-axis, then uh, and it is passing through the origin, so it will be uh, the x-axis itself, right? Anything which is parallel to x-axis and it is passing through origin also, that is the line itself, which means the x-axis itself. So we know that the here is question number two. So if it is the line itself, then it's and if it is passing through the origin, so its Cartesian form will be x minus 0 upon 1, because the unit vector of along x-axis is 1 comma 0 comma 0. So it is parallel to x-axis only. Then y minus 0 upon 0 and z minus 0 upon 0. So this will be the answer. That's an easy question. Or you can write it like this: x upon 1, y upon 0 equal to z upon 0. This is the answer, right? Now, the third question is an easy question. Two lines are perpendicular, and we have to find the value of k. And we know that if two lines are perpendicular, then their the b1 dot b2 vector is always 0, right? So a1 a2 plus b1 b2 plus c1 c2 will become 0, and you can easily find out the answer. So you can do it by yourself. Similarly, we have to find the shortest distance between two lines. Again, the same kind of question. So you can do the fourth question also by yourself. I'll do the fifth question here. Fifth question says that there are two lines given and a point is also given. We have to find the vector form of a line which is passing through a point and perpendicular to the given two lines. If it is perpendicular to the given two lines, then the line must be parallel to the cross product of those two lines, right? Because as I told you that cross product of any two vectors is always perpendicular to the to both the um, vectors which are involved in it, right? Like a cross b vector is perpendicular to a vector as well as b vector. So it must be parallel to another vector which is perpendicular to the line, right? Because suppose there is a line and there is a perpendicular line to it, and if we find out b a1 a cross b here, which is perpendicular to the plane of a cross b like this, then it will be perpendicular. If it is perpendicular to the plane and the given line was also perpendicular to the plane, then these two must be parallel to each other, right? So this is the way in which we can do the question. So now, first of all, we have to find out the B1 cross B2 here, because according to the given equations, we have B1 vector and B2 vector. We have to find their cross products. I, J, K, and we have 3 minus 16 and 7, and another is 3, 8, and minus 5. So if we do this, you will get it as 2i plus 3j plus 6k. After solving all this, you will get this answer, right? Now, also it is passing through uh, a point. Let us consider it as a vector. So it is passing through the point 1 comma 2 comma minus 4. So it is 1 plus 2, oh sorry, I plus 2j minus 4k. So therefore the R vector, the resultant vector, is given by a vector plus lambda b vector. And let us consider this as b vector. So it will be equal to I plus 2j minus 4k. plus lambda into 2i plus 3j plus 6k. And this will be the answer, right? This is how we can do the question. Okay, thanks.